Hello, my name is Paul Geyer, and I'm here to chat with you today about electrical safety when working around aerial power distribution lines. This is what I'll be talking about today, how the work will be broken down. By way of introduction, this is just a little bit about me and what I've been doing for the last few decades. This discussion includes specific requirements for poles and structures, pole-mounted equipment, and aerial lines. Requirements addressed include pole handling and erection, climbing and working on poles, stringing of lines, working around pole-mounted lighting and other equipment, tool handling, and tree and brush trimming adjacent to an aerial line right-of-way. Additional safety requirements are needed for aerial line work since climbing poles is often necessary. Not all work can be accomplished from aerial lifts. Electrical workers must both recognize electrical hazards and be trained how to prevent falls. This includes training in safe climbing procedures when the structure design cannot accommodate optimum fall protection load requirements. Only workers who meet qualified climber requirements are permitted to do work requiring climbing poles or trees. Each owner must establish these requirements for both activity personnel and contract personnel. They must apply to all persons whose work involves climbing. Comply with the requirements of OSHA 29 CFR 1910.269Q overhead lines. The majority of the work will be done in an elevated position above ground level. Climbing aerial line structures such as poles may be required. Situations with limited structure access can prevent use of an aerial lift bucket truck. The structure design may not accommodate positive fall protection load requirements. Climber requirements include the following. Physical fitness required for climbing should be documented not only by an annual physical but also be validated by supervisory observation. Climbing duties should be a part of routine job activities, not an occasional occurrence. A minimum of 2 years of documented climbing training should be completed. Experience should include hazard recognition and hands-on training incorporating appropriate safe climbing practices and rescue training. Demonstrated proficiency is required on structure types similar to those that are to be climbed and should show that these structures have been climbed on a routine basis within the last 5 years. A worker in training may function as qualified only when working under the direct supervision and observation of a qualified climber. Precautions are necessary in handling poles safely. Poles are long, heavy, and treated with potentially hazardous pesticides and preservatives. They pose hazards to the workers involved in installation and dismantling operations. Additionally, mistreatment of poles during installation may degrade their ability to meet service requirements and could endanger those workers who climb them. The authorized individual in charge must either do it themselves or assign a crew member to direct the handling of poles and give all signals when poles are being lifted or handled. Poles must, whenever possible, be handled starting from the top and the end of the stack. Workers must roll poles away from them using cant hooks or bars. Poles must not be caught with cant hooks while in motion. Whenever possible, carrying hooks must be used when carrying poles. Warning: creosote, which is applied to poles as a preservative, can cause skin burns on contact. The following precautions must be taken to avoid burns. Keep arms covered with long-sleeved shirts when handling poles. Always wear gloves. Keep neck well covered with a collar or a handkerchief. Keep trousers as long as practical to protect ankles. Never rub eyes or wipe perspiration from face using hands or shirt sleeves after they have been exposed to creosote. Protect hands, arms, and face with a preparation made up of 1 part gum acacia or gum tragacanth and 3 parts lanolin where direct contact with creosote is likely to occur. If this preparation cannot be obtained, acceptable protection may be provided by petroleum jelly, such as Vaseline. First aid treatment must be obtained immediately when bare skin or eyes come in contact with creosote. Poles are usually shipped to an activities pole storage yard using flatbed railway cars on which they are secured with skids, stakes, slings, and binding. Removal is safe if done properly. The principal objectives are to unload poles so that none are broken and so that the poles do not roll onto any worker. Skids, rope lines, and slings must preferably be 1/2 inch or 5/8 inch wire rope. These must be inspected to ensure they are in satisfactory condition for the operation. All binding wires, stakes, and other fastenings must be inspected for weak or broken areas before unloading. Always pre-position lines as necessary to restrain loads when stakes and binding wires are cut. The authorized individual in charge must determine that all workers are safely in the clear before permitting binders or stakes to be cut. Binding wires must be cut with long-handled wire cutters. Never cut binders from the top of the load. Only 1 person must be permitted on top of a loaded car at a time. No one must be allowed on top of a carload of poles to cut wires, or if any wires or braces have been cut or removed. Once on the ground, the poles can be positioned by the use of cant hooks. Special precautions must be taken while using these hooks. Hooks must be kept sharp and must be protected when not in use. The hook bolt must be inspected periodically for wear. If a worn hook bolt breaks in use, sudden and possibly severe injuries could result. Injuries most often occur when a pole handle breaks or the hook comes out. Be sure the hook is firmly set in the pole. The cant hook is a 1-worker tool. It is likely to break if 2 workers double up. If a job requires 2 workers, 2 cant hooks must be used. Before moving the pole, make sure that there are no tripping hazards near the workers. Stand so the pole is rolled away. Pulling the pole allows the pole to roll on a foot or crush a leg. Be particularly careful if the pole is rolled over a hump, since the pole could roll back when the grip and position of the hook is changed. When moving a pole by hand with a pole cart or with the truck derrick, warn anyone nearby who could possibly be struck. Station a worker with a red flag to warn or stop traffic if necessary. Poles that are stored for considerable periods must be stacked above the ground on racks. The racks must provide ventilation and properly block the poles to keep them from shifting or rolling. Never store poles with cross arms, braces, steps, or hardware attached. Poles must be stored according to size and to make them as accessible as possible. Maintain an area around stored poles of at least 10 feet free of grass and weeds. Provide sufficient space under poles to permit removal of leaves and debris. Poles stored temporarily on or near roadways before erection or removal must be placed as close as possible to the curb or edge of roadway as is safe. However, never store poles at points along the road where there are sharp turns. Do not place the poles where they interfere with traffic, driveways, or walkways. Place each pole so that its top points in the direction of traffic. Poles temporarily stored along side highways must not have cross arms attached. When laid on an incline, poles must not be placed where they can interfere with drainage. The authorized individual in charge must decide whether danger signs by day or red lights at night are required. Poles extending more than 4 feet beyond the back of a truck or trailer will have warning devices attached. Attach a red flag by day and a red light by night to the rear end of the poles being hauled. The red flag or light must be visible from the sides and rear. Observe all local and state highway regulations when poles are transported over off-vicinity highways. Poles for new area lines are often installed by contract workers. However, activity workers may need to install poles to replace storm-damaged, insect-damaged, or decayed poles. Remember that poles and guys must be properly located relative to the local activity property line or utility right-of-way. If new poles are to be set adjacent to existing poles to be dismantled, new holes must be dug. Power tools are available for digging, such as power borers or augers, and only qualified personnel must use these tools. Rock cutting drills are generally a safer alternative than the use of explosives where rock is encountered. Many pole holes can be dug by hand if power diggers are unavailable or cannot be used. The area where poles are to be set must be scoped and all utilities identified and marked. Special care must be taken when digging close to underground energized cables and circuits. Digging a pole hole involves significant hazards that can cause major injuries. These hazards range from electrocution, shock, vehicular hazards, crushing injuries, eye injuries from flying dirt and rocks, blisters on the hands from the use of hand tools, and foot and leg injuries resulting from falling over tools, particularly shovels that have been left turned up. Cover all open pole holes as soon as they are dug when other related work must continue near the hole, except when the pole is to be immediately set into the hole after digging. Covers must be at least 30 inches in diameter and must be strong enough to support 2 men. Place 4 or 5 shovels of soil on the cover after it is placed over the hole. If necessary, also set up cones to secure the area. Casings may be required in sandy or swampy soil to prevent the sides of a hole from caving in. Casing covers are required if the pole setting is not done immediately. Pole setting is a hazardous job even with experienced personnel using the best equipment. The methods authorized for manually setting poles are the pike pole method, the winch line method, and the gin pole method. The use of a line truck is the preferred method whenever possible. Figure 1 illustrates the pike pole method. This is the earliest method of raising poles and may be used when a truck cannot be brought in. A jenny initially supports the pole and a cant hook keeps the pole from rolling. The bumper board protects the wall of the hole from being caved in by the pole butt. Pikers lift the line pole by punching into the pole the steel spikes of the pike poles. The number of pikers required increases with the pole length as shown in Table 1. Table 1 indicates average crew size required to raise poles by piking. Table 1 indicates average crew size required to raise poles by piking and the configuration of the raising operations. Before setting a pole, the authorized individual in charge must ensure there is a clear working space and that all movable obstacles are removed from the area. Personnel must not wear safety harnesses, climbing belts, or climbers when setting poles. Tools or other items must not be substituted for bump boards. Always use a jenny to support the pole until it is high enough to use pikes. Only experienced workers must use the jenny. The angle of contact between the pole and jenny must be maintained as close to 90 degrees as possible. At least 3 experienced workers must be used in addition to the authorized individual in charge. 1 person must handle the butt of the pole and a minimum of 2 side pikers are needed. Inexperienced workers used in this work must be thoroughly instructed on the hazards involved. A 2-legged jenny must be used. It is the responsibility of the authorized individual in charge to verify that all pole lifting tools are in acceptable condition prior to the lift. Figure 2 illustrates the winch line method. When erecting poles by truck winch and winch line, ensure all workers are in the clear. Depending on the pole size and class, up to 3 experienced workers may be needed in addition to the authorized individual in charge. For a safe lift, the gins or maneuverable rigging assembly must have enough teeth to handle the pole. Pikes must not be used in combination with a winch. Side guys used in setting poles or structures must be attached to pencil bars driven into the ground. The lines or other guy lines must never be wrapped around any worker's body. Figure 2 indicates the winch line method. With regard to the gin pole method, in setting extra heavy poles or those 45 feet or longer, it is best to use a tackle block attached to another pole rather than the pike pole method. The other pole is called the gin pole or maneuverable rigging point and is either existing or is especially installed for the purpose of raising the new pole. The gin pole must be guyed sufficiently with not less than 5/8 inch diameter rope to hold it erect under the strain of the load. When the new pole is raised using power from a vehicle, the temporary guy must be run from a snatch block at the bottom of the gin pole to a substantial anchor. This prevents the gin pole from slipping at the ground line. Otherwise, the gin pole must be set in a hole of depth 1 to 2 feet. Pole setting trucks must be parked where feasible so that the boom will never be closer than 10 feet to energized overhead conductors. When the work is to be done near energized conductors and it is impossible to lower the boom sufficiently to be in the clear, the conductors must be placed in an electrically safe work condition before work is begun. When it is not possible to de-energize the conductors and work must be done with the boom close to energized conductors, all personnel must keep away from the frame of the truck and must not touch the pole. Pole guards or insulated blankets must be used. Never touch with bare hands a pole that is being set in an energized line. Instead, an insulated cant hook or dry rope around the butt of the pole may be used to guide it into the hole. Only an electrical worker qualified as a journeyman or craftsman must be permitted to guide poles through energized conductors. This operation is classified as energized work and appropriate permits and/or authorizations must be obtained. When a pole of any type is being set or removed between or near conductors energized at more than 600 volts, the pole, winch cable, and truck frame must be effectively grounded with protective grounds. Lines must be covered with rubber protective equipment to prevent poles from touching energized parts, and workers must use rubber gloves. Attach a protective ground to the frame of all winches. If the pole is to be erected by hand, pikes, the protective ground must be attached to the pole using an approved grounding band approximately 15 feet from the butt end. Install and use pole guards. In all cases, exercise extreme care to keep the poles from contacting conductors. Wood poles must not be considered as providing adequate insulation from energized lines. Backfill the hole after the pole has been placed. Use pikes to align the pole while backfilling. Pikes must not be removed until sufficient tamping has been done to prevent the pole from falling. Pole dismantling from a live line is a particularly hazardous operation. Exercise extraordinary care. Each pole must be restrained in at least 3 different directions by ropes before any work proceeds on the pole. This may be done by the following procedure. Make 2 turns around the pole with a sling and tie securely. Tie 3 lines around the sling at the proper angles. Insert pike poles under 2 sides of the sling well up the pole. Snub off securely by pencil bars driven into solid ground or by any other substantial snub. Always check the pole to see if additional support may be necessary because of pole conditions or strains. Determine the condition of the pole butt before removing guys or wires, and support the pole with additional pike poles or temporary guys if necessary. When an old or reinforced pole is to be dismantled, guy it sufficiently to withstand any altered strain on it. Be sure to include the weight of personnel who are to work on the pole while dismantling. When changing the strain on a pole, the authorized individual in charge must ensure it is sufficiently guyed to stand the altered strain and prevent the pole from falling. Workers must not climb a pole that is under an abnormal strain. A truck equipped with an A-frame and backed up to the pole can be used to restrain the pole. The top of the A-frame can be tied by the winch line to the pole. The pole at the ground line level can be securely tied off to the truck. In locations where poles cannot be lowered with a rope or derrick, a guide line must be attached so that the pole moves in the desired direction. All members of a crew who are not actively engaged in pole removal must stand well clear in case the pole must fall. Where appropriate, stop all pedestrians and traffic during pole removal. When a pole is being removed, dismantle the pole before beginning the excavation around the butt. Workers must be familiar with the general rules for climbing poles and approaching the overhead work area. The differences of climbing wood poles as opposed to steel towers and the dangers inherent in crossing overhead structures from one side to another. Do not work at the base of a structure or a pole while others are working above. Before climbing a pole, the worker must first determine what circuits are energized and their voltage, and any unusual conditions which might pose a hazard. The types and locations of circuits and the direction of feeds, the best climbing space to avoid all live wires, grounded wires, and signal circuits. Ensure there is an ample supply of rubber protective equipment on hand to completely protect the worker on the pole from all live wires, grounded wires, and signal circuits. Only one worker is permitted to ascend or descend a pole at any one time. Other workers must be in place on the pole or on the ground before the worker ascends or descends the pole. Extraordinary care is required of the workers when it becomes necessary for one worker to work above the other. Before climbing poles, ladders, scaffolds, or other elevated structures, riding span wires, messengers, or cables, or entering cable cars, bosun chairs, or similar equipment, each worker must first ensure the structure or device is strong enough to sustain the worker's weight. The type of pole to be climbed affects the precautions that the worker must take in regards to climbing equipment and procedures. All types of poles must be safe to climb in terms of being strong enough to bear the weight of the climbers and their tools, and in having adequate climbing space. Before allowing anyone to climb on a pole, the authorized individual in charge must ensure the pole is inspected, i.e. hammer tested and pike pole rocking test, and that it can be safely climbed based on the following. Determine the age, physical condition, and treatment of the pole. Do not climb a pole unless you are sure it can safely hold your weight. Before climbing, inspect the pole for the following. General condition: buckling at the ground line or an unusual angle may indicate pole has rotted or is broken. Cracks: horizontal cracks perpendicular to the grain of the pole may weaken the pole. Vertical ones can pose a hazard to the climber, and employees should keep their gaffs away from them while climbing. Holes: hollow spots or woodpecker holes can reduce the strength of a wood pole. Rotting and decay: are cutout hazards and are possible indication of the age and internal condition of the pole. Knots, one large knot or several smaller ones at the same height may be evidence of a weak point on the pole. Depth of setting, evidence of the existence of a former ground line substantially above the existing ground line may be an indication the pole is not longer buried to a sufficient extent. Soil conditions, soft, wet, or loose soil may not support any changes of stress on the pole. Burn marks, burning from transformer failures, or conductor faults could damage the pole. Wood poles should be inspected and tested by the qualified employee prior to any climbing activities using one of the following methods. The hammer test. Wrap the pole sharply with a hammer weighing about 3 pounds starting near the ground line and continuing upwards circumferentially around the pole to a height of approximately 6 feet. The hammer will produce a clear sound and rebound sharply when striking sound wood. Decay pockets will be indicated by a dull sound or a less pronounced hammer rebound. Also, prod the pole as near the ground line as possible using a pole prod or a screwdriver with a blade at least 5 inches long. If substantial decay is encountered, the pole is considered unsafe. The rocking test. Apply a horizontal force to the pole and attempt to rock it back and forth in a direction perpendicular to the line. Caution must be exercised to avoid causing power lines to swing together. The force may be applied either by pushing with a pike pole or pulling with a rope. If the pole cracks during the test, it should be considered unsafe. Determine if the configuration of conductors and equipment on the pole will provide adequate climbing space. Determine if the removal of supporting conductors or guys may affect the safety of workers. Determine if the poles to be climbed can be supported in such a way as to safely support workers on the poles. Pikes are not acceptable as a support method while personnel are working on poles. Now some comments on pole climbing equipment. Make sure each worker who is authorized to climb has a full set of climbing equipment. Never loan or borrow a set of climbing equipment. Carefully inspect climbing equipment before each day's climbing activities. Examine leather for cuts, cracks, and enlarged buckle tongue holes. Examine metal parts for cracks, wear, or loose attachments. Examine climbers' gaffs for proper cutting edge, length, and shape. The authorized individual in charge or a designated worker must inspect all tools, safety devices, and other equipment in use on a weekly basis. Any item that is not considered safe must be condemned regardless of ownership and must not be used. Ensure that employees understand that fabricated or purchased fall protection must meet or exceed the requirements outlined in ANSI Z359, Safety Requirements for Personal Fall Arrest Systems, Subsystems, and Components, and with ASTM F887.04, Standard Specifications for Personal Climbing Equipment. Body harnesses meeting the requirements of ANSI Z359 with straps or lanyards must be worn to protect personnel working at elevated locations on bucket trucks, power poles, towers, platforms, and other structures. Inspect body harnesses and straps before use each day to determine they are in safe working condition. Use body harnesses instead of body belts for fall protection. Equipment sets each consist of a body belt or body harness, a pole strap, and climbers, an assembly of gaffs, leg straps, and pads. The Edison Electric Institute provides an excellent document entitled Use and Care of Pole Climbing Equipment, which is appropriate for use in training for pole climbing certification. Climbers must meet the following requirements. Leg iron shank to be made of spring steel. Gaff spur to be forged from tool steel. Leg iron length should be at least in the range from 15 to 18 inches from the instep to the end of the shank. Leather straps must be at least 1¼ inches wide and 22 inches long. Pads must adequately protect the calves. Climbers, pull straps, and other leather items that have any of the following defects must not be used until repaired: cracked, dry, or rotten leather, leather which is worn thin, cuts or worn places which are of sufficient depth to weaken the leather, broken stitches or loose rivets at buckles, D-rings, or snaps, snaps which have weak springs behind the tongue or loose rivets which hold the tongue, loose tongues in buckles, buckles, D-rings, or snaps that show considerable wear or which have been cracked or bent. Leather equipment in regular use must be cleaned and dressed at least every 3 months, and more frequently when the equipment is wet from rain or perspiration or is soiled with dirt or mud. Leather equipment not in regular use must be cleaned and dressed at least every 6 months. Wipe off all surface dirt and mud with a sponge dampened, not wet, with water. Never use gasoline or other cleaning fluids as they tend to dry out and harden the leather. Wash leather with a clean sponge in clear, lukewarm water and a neutral soap, free from alkali, preferably saddle soap. Thoroughly wash the entire length of the leather and work the lather well into all parts. Place in a cool area to dry. Leather must be dressed with oil after each cleaning. Use a small quantity, about 4 teaspoons of pure neat's foot oil per set of equipment, and apply it gradually with the hands using long, light strokes while the leather is still damp from washing. Leave in a cool place to dry for about 24 hours and then rub the leather vigorously with a soft cloth to remove all excess oil. When safety harnesses, belts, and straps are not in use, they must be stored in designated compartments on the service truck or other suitable location to protect them from damage. When stored, climbers must be wrapped in pairs and fastened with their straps. Keep climbers, straps, and pads in good condition at all times. Inspect climbers before each use to detect nicked or dulled cutting edges on the gaff. Check them as soon as possible after striking them against hard objects such as pole hardware or nails. The worker must inspect climbers in regular use at least weekly. If any of the following conditions are found, repair or replace the climbers before use: loose gaff, nicks and depressions in the gaff, ridge of gaff not in alignment, dull gaffs, broken or distorted gaff points, broken loose leg or foot strap loop. Excessively worn, cracked, or torn straps and pads, enlarged buckle holes in the straps, broken or damaged strap buckles, fractured or cracked leg irons and stirrups, excessively worn stirrups, fractured leg iron sleeves, broken or loose rivets or screws on sleeves and straps, defective strap rings, broken or damaged loop clip-on straps, gaff guards not in good condition, improper length of gaffs. Gaffs must be at least 1 1/4 inches long, measured from the point of the gaff to the point of contact with the stirrup on the underside. Sharpen climbers using a gaff shaping bit as follows. Place the climber between wood in a vise with the leg iron horizontal and the gaff on the top side. Use a smooth cut file and finish with a sharpening stone. Never grind with an emery wheel, as this takes the temper out of the metal. The outer ridge of the gaff must never be filed. To obtain the proper width, a file may be used on the rounded portion. Apply strokes that follow the contour of the gaff. To sharpen the gaff to proper thickness, file the metal from the flat inner side of the gaff. Care must be taken to prevent notching the leg irons or stirrup. Use forward motions toward the point and down to edges of the underside of the gaff. Do not allow rocking motions of the file, because this can round the edges of the gaff. After the proper thickness has been reached, the underside of the gaff must be straight to within 1/16 inch of the point, then round it slightly toward the ridge of the gaff on a radius of 1/4 inch. Additional sharpness may be obtained following filing by dressing the underside and rounded portion of the tip with the honing stone. Burrs along the edges must also be removed with the stone. Never use a climber with a gaff shorter than 1¼ inches as measured on the flat side. Restore damaged or dull gaffs to original shape, refer to Figure 3, by filing and honing, see Figure 4. If gaffs cannot be restored, replace them. 3 methods are normally used to determine if gaffs are properly sharpened. Gauging method. The gauging method is used to determine the length, width, and thickness of the gaff and profile of the point. Reference lines are scored on the gauge with slots provided to determine if the gaff length is satisfactory. Most gauges also provide a contour test to determine if the point is properly curved. Openings are provided for determining if the point is too keen. Each manufacturer makes a gaff gauge to be used with its own climbers. Thus, gaff gauges are not usually interchangeable. Manufacturer's instructions must always be used if available. The thickness slot in the gauge is used to measure the thickness of the gaff at 1/2 inch from the point. These measurements are made with the outer ridge of the gaff resting flat against the part of the gauge containing the scored lines. If the point of the gaff extends beyond the farthest line, the gaff is too thin. If it does not reach the nearest line, then it is too thick. The width slot on the gauge is used to measure the width 1/2 to 1 inch from the point. The same methods and reference lines are used in measuring for thickness. A minimum length reference line is provided intersecting the thickness measurements to determine if the gaff meets minimum lengths. Figure 3 is an indication of a comparison of correct and incorrect gaff shapes. The plane test method may be used with the gauge or independently if the gaffs are sharpened by machine process. The test is made by using a soft board to determine if proper sharpness has been reached. Place the climber with the gaff side down and parallel to the board without applying downward pressure above the gaff. Push the climber along the board. If the gaff is properly contoured and sharpened, it can dig into the wood and hold within approximately 1 inch. If the climber continues to glide along the board for more than 1 inch, additional honing is required. After the plane test has been made, it can be supplemented by applying a cutout test. Jab the gaff into the board at about a 30-degree angle for approximately 1/4 inch. Bring the leg iron down against the wood while applying forward pressure. One hand holds the leg iron and the other holds the stirrup. If the gaff cuts out within 3 inches, it is improperly sharpened. The pole cutout method is used after climbers have been machine sharpened or gauged, and as often as required thereafter. Perform a pole cutout test in accordance with Table 2 before climbing. Check failed gaffs with a gaff gauge to determine the reason for failure and correct the deficiency. Table 2 indicates the in-use check of pole climber gaffs. To protect the gaffs, use gaff guards when climbers are not being used. They must also be used when other tools and materials are stored or transported along with the climbers. Note, climbers must never be stored or transported without appropriate gaff guards. Do not wear climbers when working on the ground, traveling to and from a job, piking poles, walking through underbrush or rough terrain, or riding in motor vehicles. With regard to concrete and steel pole climbing, OSHA standards 29 CFR 1910 and 1926 require fall protection for certain working heights. Acceptable fall protection includes the use of standard railings and toe boards, floor opening covers, or a personal fall arrest system. A body belt is no longer acceptable as part of a personal fall arrest system. Fall protection is required for operations and maintenance activities when personnel are required to work at a height of 4 feet or more above ground or the next lower level. For construction activities, workers must be protected from falls when working at a height of 6 feet or more. An approved positioning device that limits a fall to less than 2 feet must be used when a worker needs to be supported on an elevated vertical surface such as a wall or utility pole and work with both hands free while leaning. A proper anchor point must be identified and evaluated by qualified personnel before an appropriate system can be selected. OSHA regulations accept pad eyes, bolt holes, and other sturdy structures capable of supporting 5,000 pounds per attached worker. Positive systems have an anchor point independent of the support method, a harness to hold the worker, and a connecting device between the anchor point and the harness. Harnesses must only be used for the personal protective purpose for which they are designed. In addition to fall arrest harnesses, there are fall arrest positioning, fall arrest suspension, fall arrest retrieval, and retrieval positioning harnesses. Manufacturer's instructions in regard to height and weight must be followed for sizing of the harnesses and their connecting devices, and for inspection and maintenance of the complete systems. All equipment must be taken out of service and inspected for damage after being subjected to a fall impact. Workers authorized to climb must have a complete set of approved tools. The number of tools carried in tool belts must be kept to a minimum. Tools must not be carried in safety harnesses. Only after a determination of the pole's safety, the collection of necessary climbing equipment and work tools, and obtaining assurance that the line is placed in an electrically safe work condition or that the energized work is authorized to be carried out, can the worker start climbing. Protect hands and arms by wearing gloves and long-sleeve shirts. Refer to pole inspection requirements before climbing. Arrange tools and equipment to allow both hands to be free for climbing. Do not stand on mailboxes, signs, fire alarm boxes, or similar equipment that may be attached to the pole or located near it. Do not race up and coast down poles. Do not use safety straps while climbing except when climbing over slippery or ice-coated cross arms or timbers. Whenever the hands are apt to slip off, a safety strap must be used. The use of rope safeties is prohibited. Remove all signs from a pole before any worker climbs or does any work above them on a pole. It is not desirable to have signs on poles, but some signs, such as street signs, may be necessary. If street signs are removed, they must be replaced as soon as possible after work is completed. Climb on the high side of a raked or leaning pole, if possible, but do not climb on the side where the ground wire is attached. Avoid grasping pins, brackets, cross arms, braces, or other attachments that might pull loose and cause a fall. Never slide down any type of pole or any guy wire. If it is impossible to use climbers for ascending and descending such places, ladders or other means must be used. Do not ride overhead guys or cables. This is not intended to apply to cables installed for river crossings or otherwise designed to support workers in suitable conveyances. If more than one worker needs to work on the pole at the same time, the first worker must reach working position before the next worker leaves the ground. Ordinarily, no worker must work directly under another worker on the same pole. When this is necessary, take extreme care to prevent tools or other objects from being dropped on the worker below. Minimize the number of tools carried in tool belts. Keep all other tools on the ground until they are required. Needed tools must be raised and lowered by means of a canvas bucket attached to a hand line. When carrying a hand line up a pole, leave the hand line uncoiled with one end attached to the rear of the body belt or harness. When climbing with a hand line, take care to prevent the hand line from fouling on any pole attachments. Wear appropriately rated arc flash personal protective equipment as specified. Discontinue work during adverse weather conditions such as thunderstorms, rain, high winds, and icy conditions. In bad weather, do not climb poles except for emergency restoration work. Wooden pole climbing precautions include seat gaffs securely. Be especially vigilant when the pole is icy or sleet covered. Use pole steps whenever they are available, but only after checking that they can be used safely. Use climbers carefully on the pole to avoid injury to another worker on the pole. Be careful to avoid weather cracks, checks, knots, shakes, rots, and hard places which might cause gaffs to cut out. Remove any tacks or nails which may impede safety. Precautions for concrete and steel pole and tower climbing. Always make sure that gloves and shoe soles are in good condition and free from grease or other lubricants. Many falls are caused by slick work gloves or slick shoes. Rough cord sole shoes or boots are recommended. Be particularly careful in wet or icy weather conditions. Carefully wear and regularly inspect the safety harness, since steel and concrete surfaces can easily damage or cut the harness. Never change the amount of strain on a pole by adding or removing wires until you are sure that the pole can stand the altered strain. If in doubt, consult your authorized individual in charge. Wear safety straps at all times when handling wires or apparatus while on a pole or structure. The following precautions must be taken. Be careful in attaching snaps to D-rings. Visually ensure that the snap keeper is fully closed in the correct ring before any weight is applied to the safety strap. Always be sure that safety straps are connected and not twisted while in use. Never depend on a crossarm or crossarm pins and braces for support. Never attach safety straps above the crossarm in the top gain or around insulator pins, crossarm braces, transformer hangers, pole steps, or guy wires. If there is no crossarm in the top gain, the strap must be placed closer than 2 feet to the top of the pole. In this case, take precautions to assure that the strap does not slip off. Ideally, the strap must be below the top pole attachment, except where that attachment is above eye level. Never fasten both safety harness snaps in the same D-ring in order to reach out farther on the pole. An extension safety strap must be used or the safety harness let out so that work can be performed with the safety harness snaps fastened, one in each D-ring. Do not attach metal hooks or other metal devices to body harnesses. Metal chains and keepers must not be used. Instead, use leather straps or rawhide thongs with hardwood or fiber keepers. Care must be taken to prevent the snaps on the safety harnesses belts from coming in contact with anything that may open a snap. The tongue of the snap on the safety harness belt must face away from the body. Take the following precautions when hoisting or lowering materials. Drop material that cannot be lowered safely only if there is no danger to workers or the public. Position workers engaged in hoisting tools and materials so that they cannot be injured by a falling item. Do not leave materials and tools overhead in an unsecure position. Large objects must be securely latched. Now some comments on crossing structures. To get from one side of a double pole supported structure to the other, the worker must descend to the ground and go up the other pole unless there are adequate handholds and adequate clearances from live parts to allow safe crossing along the structure. When it is necessary to climb halfway across a crossarm to inspect middle phase insulators, the worker may climb the rest of the way across, provided that a safety harness belt can be kept strapped around a timber as a safeguard. Never cross through an open air switch unless both sides are placed in an electrically safe work condition. Do not use air switch arcing horns for support in walking timbers, since these horns break easily and a fall could result. Never walk along an H-frame crossarm with the line energized. Now some comments on stringing or removing de-energized conductors and overhead ground wires. A pre-work meeting. Discuss the plan of operation, type of equipment to be used, adjacent energized lines, necessary grounding devices and procedures, crossover methods, and safe clearance requirements before stringing or removing de-energized conductors or overhead ground wires. Work adjacent to energized lines. The worker attending the payout reel must wear rubber gloves when pulling wire over or near energized conductors and be positioned on an insulated stand of a size equivalent to or larger than a standard rubber blanket. Ground the payout reel. The authorized individual in charge must approve any deviation in grounding the payout reels. A bull line, which must be of dry polypropylene rope not smaller than 1/2 inch diameter, must be placed in position to pull the wire before attempting to string it. The bull line must be of sufficient length to reach the distance the wire is to be pulled. Fasten the wire to the end of the bull line and pull it into position. A vehicle used to pull a wire must be positioned so that the driver can see the signals of the reel operator. Both in pulling in the wire and in sagging it, the pulling must be slow and steady to prevent swinging the wires into the energized conductors. The wire must be watched carefully to prevent its hanging up on tree limbs, weeds, and other obstructions. Do not touch any conductors or wires on the ground without rubber gloves. Wear rubber gloves and use other protective devices as appropriate when wires are strung or sagged over, under, or across conductors carrying a voltage of 5,000 volts or less. Positively and constantly ground conductors carrying more than 5,000 volts during the stringing operation. Ground the wire with standard grounding devices as soon as it is ready to be dead-ended. Discontinue operations and seek appropriate shelter when notified that a lightning warning is in effect. Electrical charges can appear on the line from a lightning strike or from induced static charges from a very dry atmosphere. Be in contact with the weather service and cease outside activities when notified of a lightning warning. Waiting for an indication of lightning can expose a work crew to adverse weather conditions. Keep wires being strung along or across streets or highways higher than any expected car or truck traffic. Traffic must be blocked when this line elevation is not possible. Requirements for grounding of de-energized lines are covered elsewhere. Other grounding requirements are as follows. Permanent ground wires are installed to protect workers. All permanent grounds must be installed in accordance with the requirements of the National Electrical Code or the NESC as applicable. If the permanent grounds are not installed, the metallic case covering or mounting support of any energized piece of electrical equipment must be treated as if it is energized at full voltage. Install ground wires clear of all metallic line equipment except that which is normally grounded, hardware, and street lighting fixtures. Install ground wires on distribution wood poles with protective molding for the entire working length of the pole to protect them from damage. The entire working length of the pole is the distance from the point where the ground wire terminates near the top of the pole to 5 feet below the lowest cross arm or bracket, and from the ground to 8 feet above the ground line. Never cut an overhead ground wire or neutral wires without the specific approval of the authorized individual in charge. Always avoid opening a joint in such a wire without first bridging the joint with wire of equal or larger size. ANSI IEEE 524 provides general recommendations on the methods, equipments, and tools used for the stringing of overhead line conductors and ground wires. Safety precautions include reels. Use adequate braking to stop all payout reels. Do not touch or attempt to hand stop a revolving reel. Securely fasten the inside end of the coil wire to the reel to prevent the wire from getting loose when the wire has been extended out. If the inside end of the coil cannot be secured, a tail rope must be fastened securely to the wire before the end is reached to prevent its getting loose. Bond and ground all stringing equipment such as reel stands, trailers, pullers, or tensioners. For primary line installation, string the lines to clear the ground by an amount not less than that specified in the NESC. These minimums depend upon whether the line is above a street, consider its traffic classification, above a pedestrian way, or over or near other structures. Wire and guys that are being strung must be kept clear of any possible interference with public traffic of any type. Where it's necessary to block traffic temporarily while wires and guys are being installed, one or more members of the crew must be assigned to direct traffic. Stringing wires by personnel must normally be done by the tension method, since this keeps the conductor clear of energized conductors and clear of obstacles that might cause surface damage to the wire. Slack stringing may be appropriate for new short line extensions. Sag the lines to meet the requirements of the NESC. Take care not to put kinks into any part of the line when stringing wires. Kinks reduce the strength of the wire and may result in fallen wires later. Before changing the strains on a pole by adding wires, an engineering evaluation must be completed to ensure that the pole can safely stand the new strain. With regard to clipping in or tying wires, this involves the transferring of sagged conductors from their stringing travelers to their permanent insulator positions, where they may either be clamped or tied to insulators. Securely tie wires at each tie-in type insulator to prevent the wires becoming loose and falling to the ground. Where double arms are provided, line wires must be kept tied in to insulators on each arm. This applies to both pin and post type tie-top insulator work. Clamp type insulators must have the clamps tightened as specified by the manufacturer. Test the phase wires with a potential transformer or other means to make sure the phase wires of one circuit are being connected to the corresponding phase wires of the other circuit when it is necessary to connect circuits at any point on the line. Be sure that the phase wires are not crossed when turning the vertical angle on three-phase lines. That is, phase wires must take the same position leaving an angle as coming into it. With regard to secondary line installation, install secondary lines to meet line clearance requirements of the NESC. Lines can be single or triple wires. Workers must be particularly careful in stringing secondary services to avoid the hazards of working in close proximity to primary lines. De-energize and ground nearby or adjacent energized lines before stringing secondary wires. Take care not to injure the weatherproof covering when handling and stringing of weatherproof covered wires. Use the same general precautions as stringing wires when removing or salvaging wires. Where practical, the wire to be removed must be pulled out and laid flat on the ground before any attempt is made to coil the wire by hand or on a non-power driven reel. Never change the strains on a pole by removing wires until certain that the pole can safely stand the altered strain. Where a pole will be weakened by the removal of the wires, it must be guyed before these wires are removed. All wires must be lowered with a hand line. Use care before cutting a wire aloft to avoid contact with other wires. Do not allow lines which are being cut or rearranged to sag on or be blown against other electric power lines, signal equipment, metal sheaths of cables, metal pipes, ground wires, metal fixtures on poles, guy wires, or span wires. Do not allow wires which have been cut or which are being arranged to fall near or on a roadway where they might endanger traffic. Notify all persons working on lower levels of poles and all personnel on the ground well in advance of the cutting so that they may stand clear. No installation or removal of guys must ever be attempted without engineering guidance. Install guys to meet the following requirements. When insulators are used, they must be connected into the guy wire line before the guy wire is set in place. In new work, guys must generally be installed before line wires are strung. In reconstruction work, guys must be installed before any changes are made in the line wires, and care must be taken not to place excessive pull on the pole and wires already in position. Install guys so that there is minimal interference with the climbing space and to clear all energized wires. Provide guy strain insulators to obtain necessary insulation when required by building or safety codes. Install guys to the correct tension. Where necessary, a guy hook may be used to prevent the guy from slipping down the pole. Locate these hooks so they do not interfere with climbing and place them so they are not convenient for use as a step. Where guys are liable to cut into the surface of a pole, the pole must be protected by a guy plate at the point where the guy is attached. The plate must be well secured to the pole to prevent the possibility of injury to a worker climbing up or down the pole. Install guys so that they do not interfere with street or highway traffic. Equip guys located near streets or highways with traffic guards. Traffic guards are sometimes called anchor shields. Guy guards, traffic shields, or anchor shields must be yellow. Install guy wires so that they do not rub against messenger or signal cables. Do not use guy wire containing snarls or kinks for line work. Use guy wires of the correct length to avoid splices. Determine the condition of the pole before removing guys. Brace the pole securely if it is weak before any changes in pole strains are made. Brace the pole temporarily if the removal of guys from a pole can change the strain and present a dangerous condition. Where it is not possible to install side guys, poles may need to be braced to be self-supporting. Install pole bracing so that it does not interfere with climbing or with street or highway traffic. Pole braced guys must not be used on poles which must be climbed. Pick up insulators by their tops to avoid cutting gloves or hands on the insulator petticoats. Do not screw down insulators too tightly because their tops might break off, cutting gloves or hands. Energized work requirements are not discussed in this presentation. With regard to street lighting, the voltage level street lighting circuits might be either low voltage multiple circuits or high voltage series circuits. It's important that the type of circuit be identified and placed in an electrically safe work condition before starting work because of the different voltage levels involved. Workers must wear personal protective equipment, PPE, in accordance with the requirements when working on street lighting circuits. Street lighting lines, fixtures, and wires must be considered energized, which requires wearing personnel protective equipment unless a safe clearance permit is obtained and the line grounded. The voltage of street lighting circuits must be treated as that of the highest voltage occupying any of the poles on which the street lighting circuit is run. With multiple street lighting circuits, they must be treated with the same precautions as the circuits to which they are connected, unless the circuit is located on a structure with a higher voltage wire, in which case it must be considered to be at the higher voltage level. Before a series street lighting circuit is opened and work is performed, the following procedures must be followed. Disconnect the circuit from the source of supply by opening disconnecting switches or other cutouts in accordance with a safe clearance permit and lockout tagout equipment. Do not depend on time switches or other automatic devices. Jumper the circuit to avoid an open circuit condition. In place street light bulbs. In replacing street light bulbs and lamp globes in street lighting brackets, there is danger of an arc developing and causing a serious damage and injury if the spring clips in the receptacle do not make contact. These springs might have been heated to the extent that they have lost their temper, or for some other reason do not close the circuit when the lamp socket is pulled out. Use approved changers with at least 6-foot handles for replacing lamps on series street lighting circuits. Workers must wear personal protective equipment when removing or installing lamps where lamp changers cannot be used. Maintain safe access for climbing space by hanging street lighting fixtures clear of the climbing space. All bolts, lag screws, and other hardware used in securing the fixtures must be cut, filed, or coated to eliminate sharp or protruding edges or points. When winding time switches and working on automatic time switches, workers must not trip the switch on without first pulling the transformer disconnects or first making sure the street lighting circuits cannot be energized. On time clocks with high voltage connections, workers must always wear rubber gloves and appropriate personal protective equipment when winding, resetting, or otherwise maintaining the clock. Some comments on working on or near pole-mounted equipment. This discussion provides precautions applicable to equipment that is mounted above grade. Be aware that some local and state safety regulations do not permit grounding of enclosure cases on wood poles when there is a possibility that an accidental contact with bare aerial lines could occur. The equipment on the activity might have been installed in accordance with these regulations. Transformers connected to an energized circuit must be considered as being energized at the full primary voltage unless positive verification is made that they are adequately grounded. With regard to surge arresters, check that the permanent ground connection is intact before any work is done. Do not climb on or strap off to surge arresters. The maintenance of switches and fuses might require temporary line modifications to permit repairs while maintaining service continuity. Engineering guidance must likely be required in preparing a step-by-step modification procedure. Both sides of fuses must be placed in an electrically safe work condition in order for repair work to proceed. Individual capacitor banks must be grounded if insulated capacitor mounting racks are not used. Provide grounding in accordance with the manufacturer's instructions. With regard to power transformers and voltage regulators, work on energized pole-mounted transformers is prohibited except for testing, replacement of fuses, and switching. Observe the following precautions during installation. Carefully inspect all frames and tackles used in erecting pole-type transformers before each use. Repair defects before the frames and tackles are used. Wherever possible, junction poles, subsidiary poles, and street lighting poles must not be used as transformer poles. When it is necessary to install transformers on junction, subsidiary, or street lighting poles, be careful to maintain proper climbing space and to avoid crowding of wires and equipment. Install transformers only on poles strong enough to carry their weight. Transformer poles must be straight and, where necessary, guide to prevent leaning or raking of the pole after the transformer is hung. All crew members must stand clear and detour traffic when transformers are raised or lowered. In congested traffic locations, the pole space must be roped off. Personnel on the pole must place themselves on the opposite side from that on which the transformer is being raised or lowered. Pole steps and other obstructions in the path of ascent-descent of large transformers must be removed. When transformers are installed, the pole climbing space must be protected so that climbing workers do not come too close to transformer cases. Pole-type transformers must not be installed until they are supplied with a sufficient amount of the appropriate oil or fluid. Phase rotation should be determined before the old bank is removed and before the new three-phase bank of pole-type transformers is installed. Check voltage and phase rotation as well as the nomenclature plate. Only qualified climbers must be allowed to climb poles to inspect and test pole-type transformers. Never stand on or otherwise contact transformer cases. Disconnect all energized connections to transformers and provide a safe clearance from all live circuits before changing or replenishing transformer oil. Do not use lighted matches or open flames of any kind when opening transformers. When installing fuses, workers must be careful to avoid contact with any live lines and with other metal surfaces even if they are supposed to be grounded, i.e. grounded lines, the casings of grounded transformers, street lighting fixtures, signal lines, signal equipment, the metal sheathing of cables, metal conduits, span wires, or guy wires. Before installing fuses in new cutouts, replace fuses or opening disconnects, workers must wear and use the appropriate personal protective equipment. Service wires must not be installed on transformer poles unless minimum separation requirements can be maintained between the service wires and the energized primary conductors or apparatus. Use at least 2 qualified workers when installing services from a transformer pole when primary conductors energized at 4,000 volts or more are within contact distance of the secondary wires. The neutral wire must be connected first when making connections to secondary buses, followed by the phase conductors. Reverse the procedure when disconnecting services. Qualified personnel must perform testing of transformers, auto transformers, and similar equipment. All temporary leads used in testing, such as secondary leads of potential transformers, thermometer leads, and recording voltmeter leads, must be securely supported on the pole and must be clear of all vehicular traffic. The positions of these leads must not interfere with the climbing space or with other maintenance work which may be required while the testing is in progress. With regard to aerial rope, properly maintained polypropylene synthetic rope, not natural fiber rope, which meets ANSI IEEE 516 requirements, must be used for aerial lines, hand lines, and tag lines for energized work. Keep rope stored in a clean, dry location and protected from damage and contamination. Rope lines used must be constructed without wire reinforcement and must be at least 1/2 inch in diameter. Hand lines are used to raise and lower light materials and tools. They may be used for holding small transformers away from the pole during raising or lowering. Throw lines are used to pull a larger rope into place for performing a task beyond the capacity of a hand line. They are small diameter ropes designed to be thrown over support objects such as cross arms or tree limbs. Bull ropes are used when a hand line is not strong enough to raise heavier equipment. They are used also for fastening temporary poles, for holding out heavier transformers, and for lowering trunks, or heavy limbs in tree trimming operations. Running lines are used for pulling several span lengths of wire at one time. A sling is a looped rope assembly used for many purposes, such as to hoist heavy equipment, for lashing tools or materials in place, for attaching a block or a snatch block to a pole, for making temporary installations such as lashing an old pole to a new pole, and for tying up line wires. A safety line is used only for lowering a worker to the ground. A snatch block is a rope sheave and hook with one side of the sheave open to avoid threading the rope through a hole. Where it is necessary to connect 2 aerial rope lines permanently, a splice must be made. No metal wire or clamps can be used in making the splices. The strength of a splice can be close to the original strength of the rope and is always much greater than the strength of a knot. Knots, friction tape, cord, or marlin must not be used in joining the two parts of an aerial rope line. Properly assembled splices are not normally bulky. Each end of the rope line must be finished, served, to prevent unraveling of the strands. A hand line must be dry and strong enough to be used as a safety line for lowering a person safely from a pole. Although the term hand line is used in the discussion above, these precautions apply to all rope lines. Hand lines must be at least twice as long as the height of the highest cross arm and equipped with single sheaves. No metal must be used on any hand line except for the use of a standard hook. Hand lines with worn or frayed parts must be scrapped immediately. Hand lines must be carried up a pole uncoiled and attached to the back of body harness belt before any work is done. A worker climbing with a hand line must take care to prevent the hand line from catching on pole attachments. Hand lines must not be pulled over sharp bends, sharp edges, or surfaces with splinters. Hand lines must be kept free from solder, oil, grease, snarls, and knots. Hand lines must not be stored while they are wet. When not in use, hand lines must be rolled up and stored in a dry and protected place. Always thoroughly dry hand lines before storing. Hand lines must never be permitted to lie on the street or highway. Where hand lines are being let out on the poles, at least one member of the crew must be stationed at a safe distance from the base of the pole to take care of the loading and unloading of the hand line and to see that the ends are kept free from all street traffic. One hand line must be kept in reserve and maintained in a dry condition to use as a safety line in case there is a need to rescue a worker from a pole. This hand line must be stored in a protected part of the truck where it cannot become wet. Tackle blocks used on maintenance work must be equipped with safety snaps to prevent wire grips and live tools from coming loose and falling. Aerial line work involves the use of portable power tools and other miscellaneous tools. Use only approved portable power tools on poles, towers, or structures. Keep electric tools and connected power cords a safe distance from any circuit or apparatus energized in excess of 600 volts phase to phase. Power cords must be adequately insulated and properly secured to prevent accidental contact with any conductor. Do not use air-driven and hydraulic-driven tools when their conducting parts can come closer than the restricted approach boundary to any energized conductor or apparatus. Cover the energized conductors or apparatus with protective equipment appropriate for the voltage involved when the minimum clearances cannot be obtained. Supply hoses must be made of non-current carrying material throughout, be properly maintained and secured in use to prevent accidental contact with any energized conductor or apparatus. Use power saws in an elevated position on a pole, tower, or structure only when approved by the authorized individual in charge. Non-current carrying metal parts of handheld portable electric power tools must be grounded unless supplied from a ground fault interrupting circuit, GFI. Approved double insulated tools and tools fed from ungrounded isolated power supplies need not be grounded. Pike pole handles must be sound and free from splinters. Spear points, gaffs must be sharp and securely fastened to a pole. When carried on trucks, pike poles must be placed to prevent injuries. Maintain cant hooks and carrying hooks in a safe condition. Never use jennies with cracked or broken legs, dull teeth, or loose bolts. Use only approved jennies. Never use pole jacks with defective releases or jacks that might slip when loaded. Use only approved bumper boards. A bumper board must be either 2 by 6 inches board of length 6 to 8 feet or 1.5 by 6 inches channel iron of length at least 6 feet. Never use wire reels with defects evident. All wire reels must have suitable brakes. Close folding type knives before placing them in toolboxes or other storage containers. Open knives must be kept in scabbards when not in use. Maintain personal tools in good condition. Keep live line tools clean, dry, and in good condition. Aerial lifts must be constructed, maintained, and tested to meet the following standards. ANSI SIA A92.2 Vehicle-Mounted Elevating and Rotating Aerial Devices, ANSI SIA A92.3 Manually Propelled Elevating Aerial Platforms, ANSI SIA A92.5 Boom-Supported Elevating Work Platforms, ANSI SIA A92.6 Self-Propelled Elevating Work Platforms. The following provides requirements regarding their use. With regard to the types of aerial lifts include the following types of vehicle-mounted aerial devices used to elevate personnel to job sites above ground. Extendable boom aerial device, aerial ladder, articulating boom aerial device, vertical tower, a combination of any of the above. The vehicle may be a truck, trailer, or all-terrain vehicle. The aerial device manufacturer shall state in the manual and on the instruction plate whether the aerial device is insulating or non-insulating. Note: insulating aerial devices do not protect personnel from phase-to-phase or phase-to-ground contacts at the platform end. When working from an insulated aerial device, the primary source of insulation will be the insulating protective equipment, personal protective equipment, rubber sleeves, live line tools, and rubber gloves. Note: only insulating aerial devices tested and rated for the application and use provided in Table 4 shall be used when working on overhead lines. Insulating device categories are provided in Table 3. This slide has Table 3, the insulating device categories A, B, C with descriptions as indicated. Table 4 indicates application and uses of aerial devices. An insulated bucket of an aerial lift is provided with a non-conductive bucket liner. The liner shall be supported by the inside bottom surface of the basket. The insulating bucket shall not have drain holes or access openings. Tools and other equipment carried in the bucket must be stowed carefully to avoid damaging the non-conductive liner. Testing shall be set by the owner in accordance with the manufacturer's recommendations and ANSI SIA 92.2. Intervals are dependent upon competent function and exposure to wear, deterioration, and other agents which adversely affect component life. Testing and inspection frequencies are shown below. Manually propelled elevating aerial platforms, ANSI SIA 92.3 boom-supported elevating work platforms, ANSI SIA 92.5, and self-propelled elevating work platforms, ANSI SIA 92.6. Whichever is applicable for the construction, type, and manufacture of the lifts, require more frequent inspection, testing, and certification as follows. A dielectric test of the bucket liner shall be conducted annually in accordance with the requirements of ANSI SIA 92.2. Perform periodic maintenance in accordance with the manufacturer's operations and maintenance manual. Perform electrical tests on insulation no less than annually in accordance with ANSI SIA A92.2 to the values referenced in the following tables. Table 5 indicates periodic electrical test values for insulating aerial devices with a lower test electrode system, Category A and Category B. Table 6 indicates insulating aerial devices without lower test electrode system, Category C. Table 7 indicates insulating aerial ladders and insulating vertical aerial towers. Table 8 indicates field tests for insulating aerial devices, ANSI SIA A92.2, Section 5432, Item 10C. All records for the annual and frequent inspections documentation shall be retained for a period of at least 3 years for manually propelled elevating aerial platforms, ANSI SIA A92.3, boom-supported elevating work platforms, ANSI SIA A92.5, and self-propelled elevating work platforms, ANSI SIA A92.6. Written, dated, and signed inspection and periodic test reports and records shall be retained for 5 years for vehicle-mounted elevating and rotating aerial devices as required by ANSI SIA 92.2. Lift controls must be tested each day prior to use if the lift is to be used that day. To determine if the controls are in safe working condition, lift controls must be tested on a monthly basis when not in use. Do not alter the insulated portion of an aerial lift in any manner that might reduce its insulating value. Ensure the manufacturer's operation manual is available with any aerial lift. Do not allow anyone to touch the truck or equipment when aerial equipment is operating near energized conductors. The vehicle must be grounded, or if not grounded, must be considered as energized and properly barricaded. Ensure that everyone in the vicinity of the truck or equipment is aware of and protected from the hazards of step and touch potential. The requirements for use of rubber or other protective equipment while working on poles and structures also apply to work from aerial buckets. Use a body harness with a secured safety lanyard for any work from an aerial bucket, basket, or platform, unless the manufacturer of the equipment precludes use of a harness based on the manufacturer of the equipment and applicable OSHA standards. Harnesses shall be arc flash rated in accordance with ASTM F88704. Do not belt off to an adjacent pole, structure, or equipment while working from an aerial lift. Use the manufacturer's provided attachment point on the equipment. Do not wear climbers while performing work from an aerial lift. Wear personal protective equipment as required. Only qualified electrical workers may operate aerial lift equipment within the restricted approach boundary distances. Any vehicle or mechanical equipment capable of having parts of its structure elevated near energized overhead lines shall be operated so that a clearance is maintained in accordance with the limited approach boundary limits for exposed movable conductors. However, under any of the following conditions, the clearance may be reduced. If the vehicle is in transit with its structure lowered, the clearance may be reduced to 4 feet. If the voltage is higher than 50 kV, the clearance shall be increased 4 inches for every 10 kV over that voltage. If insulating barriers are installed to prevent contact with the lines, and if the barriers are rated for the voltage of the line being guarded and are not a part of or an attachment to the vehicle or its raised structure, the clearance may be reduced to a distance within the designed working dimensions of the insulating barrier. If the equipment is an aerial lift insulated for the voltage involved, and if the work is performed by a qualified electrical worker, the clearance between the uninsulated portion of the aerial lift and the power line may be reduced to the restricted approach boundary distances specified. Insulated aerial lifting devices used for working on energized electrical systems must be specifically designed for that sole function. Use the aerial lift only for electrical related work. Stay clear of pressurized oil or air escaping from a ruptured line or fitting. The pump, compressor, or engine must be stopped as soon as a break is detected. All hydraulic and pneumatic tools that are used on or near energized equipment must have non-conducting hoses rated for no less than normal operating pressure. Do not exceed the manufacturer's boom and bucket load limits. Articulating boom and extensible boom platforms, primarily designed as personnel carriers, shall have both platform upper and lower controls. Upper controls must be in or beside the platform within easy reach of the operator. Lower controls must provide for overriding the upper controls. Controls must be plainly marked as to their function. Lower level controls must not be operated unless permission has been obtained from the worker in the lift, except in case of emergency. All controls must be clearly identified as to their function and protected from damage and unintentional actuation. The boom position and carrying attachment controls shall return to their neutral position when released by the operator. Note: the aerial lift may become energized when the boom or the aerial basket comes in direct contact with energized conductors or equipment. The operator must be trained in accordance with the manufacturer's operation manual and the applicable ANSI standard. Any ground safety personnel acting as the ground person during the operation of the lift must be qualified and have received training in accordance with the manufacturer's operation manual and the applicable ANSI standard. Operators must also be trained for working from aerial lifts according to OSHA 29 CFR 1910.269, 1910.333C, and NFPA 70E and 130. Drivers of aerial bucket trucks must be constantly alert to the fact that the vehicle has exposed equipment above the elevation of the truck cab and will be sure that roadways provide the necessary overhead clearance. They must avoid the need to move the truck into the opposing traffic stream by prior planning of the order of work. Any backing of the truck must be done slowly and under the direction of one person on the ground. This person must have an unobstructed view of the intended path of the vehicle. Do not move a truck with the boom elevated in working position. Booms shall be properly secured in the cradled position prior to any movement. When traveling to and from job sites, pin-on type buckets must be removed and stored on the truck or secured in a horizontal position to the boom to avoid obstructing the driver's vision. Upon arriving at the work area, legally park the truck while the vehicle and the pedestrian warning signs, lights, and barricades are being placed. Give careful consideration to the location of overhead conductors and the surrounding conditions before the truck is moved into the work position. Make every effort to place the truck so that all work areas at that location may be reached by the boom without movement of the truck. Perform a job site tailgate safety briefing, including application of operational risk management principles. Available footing for the truck wheels and outriggers must be examined carefully and extra caution exercised if there is snow, ice, mud, soft ground, or other unusual conditions. Blind, ditches, manholes, culverts, cesspools, wells, and similar construction features are additional possible hazards. Before lowering the stabilizers, outriggers, or hydraulic jacks, the operator must be certain that no persons are close enough to be injured. Wheels must be choked and cribbing may be needed to ensure stability of the truck body. When working on an inclined road or street, check each outrigger or jack to make sure a stable setup has been achieved. The truck must be approximately level as viewed from the rear. A warm-up period for the truck is usually needed at the beginning of each day's work. This time must vary with different truck makes and models and with different temperatures. Follow the manufacturer's recommendations. When lowering the boom to a cradled position, workers must stand clear of the path of the bucket and boom. When work is completed, secure aerial ladders in the lower traveling positions by the locking device on top of the truck cab and the manually operated device at the base of the ladder before the truck is moved for highway travel. One worker must be responsible for all operations required in placing the bucket in operating position, use of the bucket, and restoring it to the traveling position. This worker must check to be sure that the truck handbrake is set, the wheels of the truck chocked, and if the truck is equipped with outriggers or stabilizers, they are in the down position. If this worker has any doubt as to the stability of the truck, particularly because of the terrain, the outriggers or stabilizers must be specially checked for proper positioning before a load is lifted. When the boom must be maneuvered over a street or highway, necessary precautions must be taken to avoid mishaps with traffic or pedestrians. Use of a flagman must be considered. Workers must enter the bucket only with the bucket resting in the position for which entry was designed. Observe the following precautions. The operator must face in the direction in which the bucket is moving so that all obstructions are noted and avoided when the bucket or boom is raised, lowered, or rotated. The operator must follow the proper sequence prescribed by the manufacturer in raising the boom section. Before reaching any area containing obstructions, the operator must test all controls of the boom and bucket to ensure that they are in proper working order. The operator must suspend operations upon indication the controls are not working properly. Raising the bucket directly above energized conductors or equipment must be kept to a minimum. When possible, locate buckets to the side of lines to help workers avoid contacting energized conductors and equipment. If the work is within reach of energized conductors or equipment, a worker must be properly protected with rubber sleeves and rubber gloves of an insulation rating appropriate for the voltage level. Energized conductors and equipment must be covered with protective devices when necessary to perform the work safely. Adequate clearance must be maintained so that protruding tools must not come in contact with conductors, tree limbs, or other obstructions. A worker must always stand on the floor of the bucket, never on top of the bucket or on planks placed across the top of the bucket or materials within the bucket while performing work. Buckets shall not be altered to facilitate additional reach. A worker must not belt onto an adjacent pole, structure, or equipment while performing work from the bucket. The operator must ensure that hand lines and tools do not become entangled with the levers that operate the boom. Secure all tools not in use when working aloft. When the bucket is being used in any manner that might result in contact between an energized conductor and the bucket, boom, or any attachment thereto, the vehicle must be considered energized at line potential and the following safe practices observed for ground operation. Materials or tools must not be passed between a worker on the vehicle and a worker on the ground unless both workers wear rubber gloves and use other required protective devices. Workers operating ground controls must be on the vehicle or insulated from the ground using rubber gloves and other protective equipment. Before entering or leaving the vehicle, a worker must make sure that the boom or bucket is not in contact with or near energized equipment. Workers on the ground must not work directly below the work area of the bucket. Tools or materials must not be thrown to or from the elevated bucket. Operation of aerial lift equipment near energized electrical facilities should be done only by qualified electrical workers who may operate aerial lift equipment between the approach distances given. An approved job hazard analysis must be completed. The activity is being performed under the direct supervision of a designated person who is trained and competent in the work. The distances between energized parts and the aerial lift equipment is monitored while the aerial lift equipment is being moved or repositioned. The aerial lift equipment is grounded. No one other than necessary workers shall be within 10 feet of the equipment during its operation. Workers are to perform their work while on the equipment, not from a position on the ground. With regard to tree trimming and brush removal operations, tree trimming and brush removal is necessary to maintain the integrity of electric lines and apparatus and provide right-of-way clearance. Permit only workers certified as qualified climbers to climb trees. Work accomplished from an aerial lift must only be performed by workers qualified in use of the aerial lift. If using ladders, review the requirements for their safe use. In all cases, only qualified workers must perform work near energized lines. Trimming must be done in a manner that does not damage the tree and meets ANSI Z 133.1 requirements. The worker must be qualified to do tree trimming. Erect suitable signs and barriers to prevent the public from passing under trees being trimmed and to prevent stumbling over brush on the ground. Brush must not be piled on sidewalks or left on streets and highways overnight. Raise and lower tools with a hand line. Use only saws and pruning knives or shears for cutting limbs. Do not carry unnecessary tools up the tree. Do not hang or store tools on tree limbs. Be aware that lines may not always be de-energized for tree trimming operations. Review the rules for live line safety and for climbing and working on a pole. Especially be aware of the energized lines in the area and the relevant dangers. Workers in trees must use harnesses, belts, and safety straps. When working near energized lines, arrange the safety line so that a slip or fall will carry you away from the energized lines. Climbing trees must be avoided unless ladders or aerial lifts cannot provide the necessary access. Workers in trees must be careful to prevent contact with aerial, electric, and telephone wires passing through the trees. If climbers are used, make sure they are tree climbers approved for the bark thickness of the tree being climbed. Never use pole climbers. Use a harness and safety strap or lifeline. Place the strap around a tree limb of sufficient size to hold the worker's weight, but never around the tree limb being cut. Do not stand on tree limbs too small to support your weight. Extreme care must be exercised when working in trees that have brittle wood. Check each tree for dead or broken tree limbs when climbing. Remove unsound tree limbs during the climb. Lower cut-off tree limbs with a rope because falling tree limbs can cause injury or property damage. Before felling trees, inspect tools to be used, such as ropes, tackle, ladders, and chainsaws, to ensure they are in proper condition. Place signs warning pedestrian and vehicular traffic of the danger from work being performed. Station flagmen if necessary. Inspect each tree for obstructions, conductors, and fences in the line of fall. De-energize nearby conductors if possible. Trees greater than 25 feet tall and greater than an 8-inch trunk diameter must have ropes attached before felling. The ropes can be used to guide the tree as it falls. Always have a clear path of retreat when felling a tree. Chainsaw operators must be familiar with and follow the manufacturer's operating instructions. Carefully inspect chainsaws prior to each use. Chainsaws must be clean and sharp and in sound mechanical condition with all guards, spark arresters, mufflers, handles, and other items properly installed and adjusted. Permit only workers trained in chainsaw operation to perform the work. Clear away brush or other material that might interfere with cutting operations before starting to cut. Wear appropriate personal protective equipment when operating the chainsaw. Eye, ear, hand, foot, and leg protection are minimum requirements. Never operate a chainsaw when physically tired or under the influence of alcohol, medication, or other drugs. Do not store fuel near flammable materials. Fuel for chainsaws must be stored in approved vented containers clearly marked to show the contents. Do not start the chainsaw within 10 feet of a fuel container. Do not fuel the chainsaw with it running or hot or with open flame nearby. Brush clearance is part of electrical maintenance work to clear right-of-ways. Wear personal protective equipment, i.e. eye protection, hearing protection, and proper clothing. Cutters felling heavy brush or small trees must give sufficient clearance to other personnel. Never work so close that one worker could injure another with a swinging axe or hook. Brush chippers must be operated only when authorized. The worker must stand to the side of the chipper chute while feeding the butt end of brush into the chipper first. Use the automatic shut-off stop control at the operator's station in an emergency. Do not hang tools such as saws, axes, bush hooks, pruning shears, scythe blades, and pitchforks in brushes or small trees or out of the obvious view of other workers. Restricted personnel assigned to remove or pile brush to maintain a safe distance behind workers using the cutting tool. And that brings us to the conclusion of this brief discussion of electrical safety when working around aerial lines. I hope this has been of some value to you and will allow you to undertake this type of work safely in the future. Again, thank you very much for letting me chat with you, and have a very nice rest of the day.